The next chapter is image compression. We are going to start with introduction. Image compression refers to the reduction of the amount of data required to represent a digital image. By removing one or more of the three basic data redundancies, compression can be achieved. Redundancies may be coding redundancy, interpixel redundancy, or psychovisual redundancy. Image compression systems comprises an encoder and a decoder. Image f of x, y is fed into the encoder, which creates a set of symbols from the input data and uses them to represent the image with compression. Compression that is achieved can be numerically quantified via compression ratio, that is CR equals to NY by N2. Here N1 and N2 denote the number of information carrying bits in the original and encoded images respectively. Function IM ratio can be used to compute the ratio of the number of bits used in the representation of the two image files or variables, which is having a syntax as CR equals to IM ratio of F1, F2. Function bytes return the number of bytes in the input image, which is having the general syntax as B equals to bytes of F. To view or use the compressed image, it must be fed into a decoder and reconstructive output image can be obtained. To reconstructive output image is not an exact replica of original image, but if it is, the system is called error-free or information preserving or lossless, and if not, the system is called lossy compression with error E of x, y. Function compare can be used to compute and display the error between two matrices having syntax as RMSE equals to compare F1, F2, scale. Now, we are going to discuss about the first type of redundancy, that is coding redundancy. The statistical dependencies among the neighboring pixels causes a redundancy called coding redundancy. Each fixed length pixel is used to code the uncompressed image. The average input per source output is called the entropy of the source. If an image is emitted by a gray level source, the gray level histogram of an observed image is used to model the source symbol probabilities and generate an estimate called the first order estimate. Function entropy can be used to compute the first order estimate of an matrix having syntax H equals to entropy x, n. Next is Huffman codes. The smallest possible number of code symbols per source symbol is contained by Huffman codes when coding the gray levels of an image or output of a gray level mapping operation. The first step is to create series of source reductions. The second step is to code each reduced source. The function Huffman is used to implement the source reduction and code assignment procedures having syntax code equals to Huffman of P. All MATLAB global variables must be declared in the function using the statement global x space y space z. Function cell is used to initialize the code, which is having the syntax as x equals to cell m, n. The function sort is used to sort the vector in ascending order of probability at each iteration having syntax y, I equals to sort of x. The output is generated by using functions celldisp and cellplot as shown. The final step is calling the makeCode function as makeCode s, empty squares. Next is interpixel redundancy. It results from correlations between the pixels of an image or between the pixels of neighboring images in a sequence of images. And third is psychovisual redundancy. It is associated with real or quantifiable visual information. There is a loss of quantitative information due to elimination of psychovisual redundant data. It is called quantization. Function quantize is used to quantize the elements of the matrix, which is having the syntax as y equals to quantize x, b, type. Improved grayscale quantization method is used to recognize the eye's inherent sensitivity to edges and breaks them up by adding to each pixel a pseudo-random number. Next is JPEG compression. JPEG stands for Joint Photographic Experts Group. It is a standard which is one of the continuous tone still frame compression standards. The first step is to subdivide the input image into non-overlapping pixel blocks of size 8x8. As each 8x8 block or subimage is processed, its 64 pixels are level shifted by subtracting 2 raised to power m-1 and its 2D discrete cosine transform is computed. The resulting coefficients are the simultaneously normalized and quantized. After quantizing each block's density coefficients, the elements of the resultant are reordered in zigzag pattern. Function IM to JPEG is used for JPEG compression having syntax y equals to IM to JPEG x, quality. Two specialized block processing functions used to simplify the computations are BLK-PROC automates the entire process of dealing with images in blocks having syntax as shown. IM2call gives a matrix whose each column contains the elements of one distinct block of the input image which is having the syntax as shown. The function JPEG to IM is used to decompress a compressed image which is having the syntax as x equals to JPEG to IM of y. So this is all in this chapter. In our next lecture, we will discuss about morphological image processing. So this is all. Thanks.